Hey everyone, my name is An Pash. Hey everyone, my name is An Pasha, and today we'll be learning about a really interesting project in the whole cloud-native domain, that is kube-green. It is a sustainability project that is mainly focusing upon increasing sustainability in your Kubernetes cluster, which actually works as an operator to reduce CO2 footprints in your cluster by using CRDs, custom resource definitions, and API references majorly. Custom resource definitions are actually the are used for extending resources if you don't want to create another API server. So it is the main website of kube-green. It's really popular in the whole cloud domain. Here you can see some of the projects that will be launched in the future. Dashboard that will be mainly focusing on showing the amount of carbon footprints that have been saved after applying the changes. Right, so let's get to the props. So here's a calculator. Usually it will be calculating the number of CO2, the carbon footprints that are being saved after you have started using kube-green. Let's say that we have 11 kgs of CO2 equivalent that are used per pod every year, and we are having a total of 100 pods and 100 pods when kube-green active. Then we'll see that after using the kube-green with the sleep info and various other kind of the CRDs, majorly the CRDs will be using a lot of resources, like they would be produced in order so kube-green usually focuses on shutting down or making your resources to go sleep. We majorly have two types of environment in our cluster, that is the main development environment, and the other one is non-productive environment. The non-productive environment usually doesn't have the resources that are actually running for about 60 to 70% of the time. So they are just running for a lot. They are just running and producing a lot of carbon footprints, which isn't good for the environment, and also that is not that much efficient for the investors either. So I will see that in the result 76.2% of the CO2 have been saved after applying kube-green. Without kube-green we would have created about 21 kgs of CO2 equivalent per week, while on the other hand after using kube-green we are producing only 5 kgs of CO2 equivalent. So as a tutorial, if you want to install it or if you want to learn about this whole tool, let's get to the install part, I guess. First jump to how it works. Right, so here it is. As it says, it uses the CRDs like sleep info. As I said, it will be using a lot of parameters within your definition file of various resources. Like it will be using sleep info as one of the CRD, specifying about the weekdays for which the particular resource would be running. And it is about sleep at, wake up at, time zone. You can specify about the time zone as well. We usually have a lot of different time zones, and they can act. You can save the resources or the computational power, majorly focusing upon the different time zones. It isn't about like we are only functioning for most of the time in Asia, so we'll be focusing on Asia only, and in the night time we won't be running all those resources in the non-productive or non-development environment. It's like that. So we'll be producing different CRDs, different sleep info for different time zones, and then focus after seeing the metrics, the trend or that particular region, I would say. So we can either handle deployments or cron jobs. Cron jobs usually are the regular or the repeatable jobs that usually run inside your cluster, which includes testing, checking or restarting all of your resource and any particular resource that you mentioned. Cron is a Unix based that we usually use for the repetitive work. So, specifies about the sleep and wake up of a resource. So I said, yeah, that's pretty self-understanding. Doesn't require any. Right, so install. By the way, sustainability is a really important part of this whole cloud native domain. A lot of initiatives have been taken place by various unions and institutions, whether it is about the cloud native CNCF Cloud Native Computing Foundation. They have a separate tech community or self initiating groups as well. SIGs, you can even take part in the weekly, or they usually hold a monthly meeting about the sustainability part. They usually have a lot of projects like Kepler. I'll be delivering another video, or I'll be uploading another video about the Kepler as well. They usually provide dashboards and tell you that how much of the CO2 have been produced by your the carbon footprints that has been produced by your cluster. A lot of other really interesting thing as well. They usually they have built their own the whole architecture of Kepler on eBPF. That's really amazing, I would say. I'll produce another a whole separate video on it. So there it is. I've actually I'll be using my Minikube, as most of you people will be using it. Right, so while it is getting started, let's see what else we got. I think we also got a GitHub repository. Yeah, start the GitHub repository. A huge shout out on the socials. They are really responsive. If you want to know more about this whole amazing project, then they can reach out to you. You can even join their monthly meetings, or the tech groups, tech community groups, or the sustainability groups. Also, kube-green is a CNCF landscape. Let me show you the orchestrating and scheduling section. Yeah. They have changed their whole landscape, I guess. The appearance of the whole CNCF landscape. Yeah. Here you can see, here it is, kube-green. We have a repository with 924 stars, contributors, first commit, and everything else you can look at it. 91.45% of this whole project uses Golang as its language, so it is a really important language. I'm also learning about it and contributing through various tests and various other projects as well, on these servers and various other projects. 51 to 100 employees. Yeah, the Mia platform actually manages this whole project. It's based in Italy. The project is actually really interesting organization that is responsible for organizing and holding similar kind of amazing cloud native projects and platforms. So yeah, I think they also used to show that how much investment they got. connect them, connect with LinkedIn or Twitter or various other platforms as well. GitHub. So do we have our Omnikube started? Alright, so this whole calculation that we saw just now, this whole calculator thing, everything is being included after getting it from the survey, the whole report by goclimate.com. You can see the whole how much kgs of CO2 equivalents been produced every year on the server, every year actually. Cloud servers using 100% of green electricity, and the on-premise, actually the hyper on the hyperscale we usually will see that it will be producing 640 kgs of CO2. It is emission from non-green consumption or for premise power or self-managed servers, 655 kgs, close to 640 kgs. And a Euro 6 car, diesel car, usually produces 750 kgs of CO2, the carbon footprints, and maybe carbon footprints and many others emissions as well, the carbon monoxide and various other emissions. And this much amount of carbon footprints is produced after the Euro 6 car had traveled for about 15,000 kilometers of drive every year. That's a huge problem, I would say. It is produced on single server every year. That's a huge problem. That's why a lot of initiatives and a lot of groups have been coming together to solve this problem. Even the European Union have came ahead to fund similar kind of startups and the plants. We have so here we have our Minikube up and running. My computer required a restart, I guess. There it is. Our Minikube is up. Some pods I have deployed just now. I'll be using Lens ID. It is a Kubernetes ID that can be really helpful for monitoring our whole cluster and various resources in it, whether it is about the pods or deployments, D1 sets, stateful sets, replica sets. I think whatever you want to just if you also have an overview, then you can see 23 pods are running and 2 are unknown in the deployments, 9 are running at the moment. If there is any pending pod or which might have got any error, you can have a look at it and then perform the troubleshooting part. You can even enter into a particular pod as well. It is kube-green. So here you can see the metrics, the whole timestamp as well, and it was created, how many hours ago it was created, what's the name of it, label, everything, the container, liveness, all the labels, readiness. You can even get the vulnerabilities. It is really important. you are a platform engineer or DevOps engineer, it can help you in pacing up the whole troubleshooting part or the debugging part. So here we can see our kube-green controller. Install it. So we can apply the kubectl apply command, then customize, use if you have make as the lifecycle manager, install some of the ways by which you can install the kube-green operator on your OpenShift or operatorhub.io. It tells about the cloud compatibility, whether it is GKE, Google Kubernetes service, or the AWS EKS. So here's the configuration part. So here are some of the parameters that you can include in your definition file. The CRDs, custom resource definitions, as I said, you can include some of these parameters, like the weekdays, where the one stands for Monday. Like if you are typing 1 to 5, then you are actually referring from Monday to Friday. You can either make it sleep or you can make it up and running your any particular resource in your environment. Weekdays or sleep at all of these parameters. It's the perfect example, I would say. These all are different chunks. Yes, it's actually a lot simpler. Yeah, the weekdays 1 to 5, sleep at 20, that is 8 at night, wake up at 8 in the morning, Europe, Rome time zone. A similar way you can define about the different time zones as well. Like in Asia, if you're getting a lot of traffic in the morning or maybe early in the morning, like 4 a.m. or late at night, then you can make them all function according to your traffic metrics. You can even find and get all the metrics by exposing it to Prometheus and port TOT or some other port, either use cases, small clusters. So as the whole documentation that you can look into, some of the graphs that show that how much memory request, memory limit and memory usage are going on, and even maximum range. It is an amazing illustration, I would say. If you're really keen to look into each and every aspect, then you can just look into the whole project and move ahead with deploying your whole Kubernetes application and using this operator, this amazing project in your application. The tutorials, how you can create a cluster with kind and use cert manager as well. Cert manager is usually that's used for creating the TLS certificates and various other functions as well. You can look into it. That's one way of installing kube-green on your cluster. Test usage, create and sleep me, or these namespaces you can create in your cluster. Again, we've got some other examples as well. Certificate management, cert manager, you can either use cert manager without cert manager, the same TLS certificate, webhooks, API references. There are all the different kind of the other kind of API references as well. Like you can include some of the some references or exclude them. Mainly focus upon some of the resources in a particular environment of a cluster, patch them up, patch target, sleep info aspect. So yeah, if you have got any doubts, you can either look into the FAQs or just contact them either. I think they've also got some way to contact. And you can contact with them on the socials. So as well. I think it is on GitHub chats, I guess. Yeah. So yeah, it is an amazing project. You can do it and start using it for your own project. A huge shout out to all the team members of kube-green, the Mia platform. I'm Arun Pasha. If you don't know me, then I am the developer advocate and ambassador at Lens ID. I make similar videos about the whole cloud native landscape, LLMs, AI collaboration, DevOps, and various other tech domains majorly. Also about the security. I majorly focuses upon the sustainability, security, monitoring, AI collaboration, LLMs, WASM as well. So I'll be making a lot of videos about the WASM and various other projects like Kafka, WASM, Sidecar proxies, Cilium, eBPF. Next video will be on the eBPF and Kepler. eBPF and Cilium have been getting a lot of popularity recently. A lot of amazing projects like Kepler is built on by using eBPF and Cilium. So it's a really interesting project if you want to look into it. So yeah, thanks, and get connected to me on my socials on Twitter or LinkedIn, wherever you want to connect with me. So yeah, that's all for this video. By the way, the sustainability part is really important for getting the maximum efficiency for your whole workload. Today, the Microsoft servers went down, so it can also be one of the reason. I don't know what is the reason, but it's also one of the reason. If you have a lot of resources, a lot of different pods and different spaces which are just lying in your whole environment without being used, and using a lot of computational power, that is really dangerous for your whole application as well. It can create a lot of loopholes, and the troubleshooting can be really difficult. So projects like this kube-green, Kepler, and various other projects as well, which usually focuses upon security and sustainability part, they are really helpful, and they at the end they help in saving a lot of investors' money. Like you'll see a lot of money getting wasted, used, I would say, in finding and troubleshooting this whole problem. And this Microsoft servers going down, the Microsoft Azure cloud. So yeah, that's all for today. Thanks. To the next video.